little bit different from the previous two talks. Actually, the last talk was super interesting. One of the things we work on in my team is direct to consumer. And what we do is we do some of the technology behind the personalization and other things that you just heard about. So what I want to do in the next few minutes is talk to you about AI, what it is, how it works. I'll show you some of the technology behind the scenes and what we do at Google with it. And then I'll end with sort of how you can use all of the same technology in your own work, in your own business, on your own sites. So people heard of Google? People have used Google, right? We have 9 products with 1 billion monthly active users each. What you may not be as aware of is that all of these products run on AI. Every single product at Google has multiple AI models in it. We have thousands of AI models running. In fact, even our operations run on AI. For example, I'll show you how the data centers which run our computers are also powered by AI. So if you want to do AI, which means you want to actually leverage the power of AI and analytics with all of the data that you all are collecting, you need sort of 4 things. You need the data I mentioned, and this could be data about your users, data about your products, data about the usage of those products. This could be batch data all coming in the same time, streaming data 1 click at a time, 1 video at a time. You need to then model that data, and I'll show you what those models look like. And they have a whole alphabet soup of things like deep neural networks, convolutional neural networks, and so forth. You, of course, then need to secure all this data. This is valuable data for you. It's private data for your consumers. So it has to be private, has to be compliant with local regulations in different states and different countries. And then you need infrastructure to run all of this. When you have billions of people hitting on YouTube or Gmail or Drive, Google Drive, or any of the other products, maps, self-driving cars, right? All of this takes a lot of horsepower to run. I'll show you so how we do that. So let's just start with how AI works. AI has gone through a few phases in the last few decades. We started with this idea of knowledge-based AI, and I'll show you how we then ended up with machine learning. The idea behind knowledge-based AI was, well, the way we make smart machines is we take all of the knowledge that you and I have, and we put it into the machine, and the machine will be intelligent like we are, because it knows everything we know. So how do you put knowledge into a machine? You could either write rules, like the one on the left, for a spam checker, and just capture sort of all of the rules for a given domain. Or you could write code. You could write procedures. The one on the right is for image analysis. So you go in and sort of look at all the pixels, and you write code to process all of that. The problem with this, of course, is that for every spam checker rule you write, there's a smart kid out there somewhere that finds a way to defeat it. You're constantly keeping up with that. So that problem is the problem we call knowledge engineering. Building these knowledge bases, whether it's in rules or procedures or some other format, and then maintaining them, knowledge maintenance and management, becomes a huge problem. There's just no way to keep up. So then we got to this idea of machine learning. Well, instead of writing all these rules, let's have the machine learn them for itself, like we do, like our kids do. So here's an example from image analysis. And so writing all of that code, we give it an image, which means we give it all of the raw pixels, all of the dots in the image that we see if you sort of expand the thing and you see all the dots. And we extract features relevant to understanding what that image is. So all of the dots and the joints and the lines and the colors and the blobs and the shapes and so forth. And then we create this representation of features and run it through a classifier that will then tell you what this image is. In this case, this is the Eiffel Tower. This actually works remarkably well. The problem with this is feature engineering. All of your time goes into figuring out the right set of features to classify these things. Things like the Eiffel Tower are relatively easy. When you start to look at your industry and you're trying to figure out what are the right features of Ashwin Ram that will help determine which wine he might like on a given day with a given set of friends so that I can then go to your vineyard and get the right one, right? It's not just my demographics, it's not just my gender and my age and my income, which is typically what you go with. There are all kinds of things, and you know this, right? It's all the psychographics, all of the personalities, all of the things. I mean, how do you predict what color socks someone might like? There's just no way to do that. So feature engineering, figuring out the right set of features, becomes a huge bottleneck. So now we come to the present. We come to something called deep learning. So the idea behind deep learning is, let's give the system all of the raw data, images, or purchase data, or whatever you're trying to model, and let's have the system figure out the features as well, end to end. So this actually works remarkably well. Let me show you how it works. So this is, again, an image classification example. We are trying to figure out what animal is in your laundry basket. And instead of writing rules for recognizing cats versus dogs, or all of the sort of curves and furry characteristics you might need, let's just feed all of the dots in the image into a layer of what we call neurons, very simple computing units, loosely modeled after the human brain. Each neuron looks at its one local piece of data and performs a very fast, very simple calculation, and passes on an output to the next neuron. One layer up, you have these neurons, fewer of them, that aggregate these inputs coming from the previous layer of neurons, and again, very locally, not looking anywhere else in the image, just locally around itself, decides whether or not to pass on an activation to the next layer, and so on. And the miraculous thing is, if you do this through enough layers, these things will now produce an output, in this case, that's the dog in your laundry basket. And I'll show you they're actually more accurate than humans are at performing visual tasks. So this stuff actually works. The inspiration is, again, as a loosely model of the human brain. It's not exactly like a human neuron, but it's close in some ways. And deep learning powers all of the stuff around us nowadays, right? It's not just images. It's language understanding. It's Google translation. It's map search. It's self-driving cars. Everything runs on personalization, as we just talked about. Everything runs on deep learning. There are many kinds of deep learning models. The one I showed you is a simple model. It's called a convolutional neural network, because each neuron is sort of doing a local convolution of its local data, if you remember your math from high school. There's also sequential networks. So if you have language, you don't get the whole image at a time. You get one word at a time. And so that requires a sequential model. And there are things like long short-term memory and recurrent neural networks for that. And the state-of-the-art ones are called self-attention networks. These were invented less than 10 years ago at Google. And the idea here is that you have a lot of data. This network not just has to process the input, also has to understand what to pay attention to in the vast amount of knowledge it has and data it has that are relevant to making this particular decision. And so these networks, again, they're very complicated. They have billions of parameters, millions of layers, billions of neurons, very, very large. But they're able to learn what to pay attention to and process these things with sufficient amounts of training data to sort of train up these neurons to perform the right function. So these things seem magical, right? There's no software, there's no knowledge engineering. We didn't program any knowledge into it. There's no feature engineering. We don't have to tell it the features. So what's the bottleneck? Is there a bottleneck? Does it just work? Anyone? So there are actually two bottlenecks. One's called architecture engineering. Remember, I showed you this very complex networks. There are many different types. Someone has to sit down and sort of create the network, build the architecture of this neural network, and figure out what neurons and how they're connected and all these attention layers and make it all work. It's called architecture engineering. It's very complicated. And this is Jeff Hinton. This is one of our Google fellows. He is one of the inventors of deep learning. There are not enough Jeff Hintons, even for Google, let alone for all of you and all of the rest of the companies who want to do AI. There isn't enough expertise out there in machine learning, right? Think of all of the AI PhDs. How many people have a kid doing a PhD in AI? No one, right? So there's a severe shortage of machine learning people. So the way we solved that at Google is we built an AI that does the AI, that does architecture engineering. And the curves, I won't go into all the detail, we only have 20 minutes. But the blue curve is the AI doing better than the yellow curve, which are these human-trained Jeff Hinton types who've built these sophisticated models by hand. So the AI is actually getting better than our own experts. Good example of this you might have seen is Alphago. This was the Go playing program that Google released, this was 3 years ago, I think, 4, that defeated the Grandmaster and Go champion. Go has more moves than the number of atoms in the universe. It's the largest game we have. Alphago was this deep neural network with some reinforcement learning and other techniques thrown in, built by a team of PhDs in AI over months of work that eventually got to be better with a lot of training than the world champion. We then built Alphago Zero. This is the AI that does AI. Alphago Zero started with no knowledge, and it built Alphago for us, in a sense. What it came up with is a little bit different from the hand-engineered Alphago. In 3 days, it got to be as good as those months of work by the experts. And within 21 days of just running, chugging away, it got to be better than any Go player we've ever seen, including any programs. The way this works is, essentially, it's doing architecture engineering. It's trying different architectures and iterating through them very, very fast and just testing against itself, playing games against itself, see what wins it gets, what loses it gets, and just keeps fixing this thousands and thousands of times. And what's interesting is, remember, this thing has no knowledge. It doesn't know anything about Go. It's just as happily will learn shogi or chess or any other game you throw at it. In fact, I mentioned our data centers. It turns out that AlphaGo Zero, a version of it, was used to tune our data centers. The cooling energy in the data centers, you model data center management as a game where you win by reducing energy. AlphaZero happily learns to win that game as well. We reduced cooling energy 40% over the best tuned control systems that we were running on. Google is now carbon neutral and has been retroactively carbon neutral from the day of its founding. It's the first company to reach that. And it's all through AI. So I mentioned there were 2 bottlenecks. The second one is scale. This is Jeff Dean. He leads that AI team. He's our most senior Google fellow. He said if everyone spoke to their phone for 3 minutes, we'd exhaust all available computing resources. It's a huge amount of data, right? And now if you imagine we have these nine applications with 1 billion users each, imagine the data that's being generated. Petabytes of data every single day after day, billions of hits. How do we model all of that? So this is just roughly a curve of how much compute the best AI models take at any given time. And the TLDR is that the amount of computation that AI takes, the best AI models, if you run these massive models, is doubling every 3.5 months. Remember Moore's law, computers doubling every 18 months? AI is far outstripping the ability of our computers to keep up. We just don't have enough compute. So how do we do this? So the way we've done this at Google is we designed an AI chip. It's called a tensor processing unit. Its sole job is to perform the matrix multiplication tensor calculations that those deep networks need on the chip very efficiently. And there's one in here as well. They can be very small, right? Very, very fast. We put these into pods. So these are about 7 years into the future in terms of compute power from the best computers available right now. We then collect these pods into racks and put them into a large room called a data center. And these racks, of course, they have also storage, they have CPUs and GPUs and networking and all the other stuff you need, batteries, right, to run a data center. These Data centers are the size of small towns. They're huge. And we scatter them everywhere in the world, and we connect them up with our own fiber optic cable. Basically, it's an alternative internet. Google runs about, I forget the exact number now, about 25 to 30% of all of the internet traffic in the world on its own private internet. We don't use the public internet because it's too slow, it's too unreliable, right? Remember the 3-second or 5-second delay the previous speaker talked about, right? You don't want a 5-second delay when you're trying to watch a YouTube video from some kid in Korea who's done this new dance or whatever, right? It needs to be instant. Every one of those billion users wants instant response to everything they're doing on Google. This is how we do it. So the entire computer is distributed across the world. We call it a planetary scale computer. The whole planet is a computer in a sense. It's a giant supercomputer running Google. And that's how we get the scale that you need. So what do we do with it? Real quickly, right? We have all of these things. The key part about AI, and this also ties back to your business, the AI has to eventually interact with people. It has to understand our language. And I mean not just natural language, English or any other language, but conversation, vision, videos, documents, catalogs, right? All of the stuff that we use to communicate with each other with, spreadsheets, right? AI has to understand all of that, because that's how we interact. So some of the examples, right? Google search runs on the same kind of deep learning AI. We can predict for every user at any given time which results of all of the matching results they're going to want to see with very high accuracy. Speech, about over a quarter of the searches now are done through voice. You can pick up a phone and just talk to it. And all of that runs on AI. I don't have time to run through a demo. If you Google for this Google Duplex demo, you'll hear it. But the conversational AI, the conversational back and forth with humans, is now pretty much indistinguishable from a human voice. It just sounds completely human. And if you've got, for example, if you've got a Pixel phone and you get a call in, you can have your phone answer the call for you. It identifies itself as your assistant, because we don't want to fool people. And it'll talk to a person. It'll call a restaurant, make reservations for you, completely human-like. We can also recognize the voices, the sounds of other animals, like birds and other animals. Looking at vision, right? This is in Google Photos. If you're like me and you have tens of thousands of photos in your photo library, like I do, you've given up trying to organize them. I don't organize them anymore, because I can say, show me photos of that vacation on a beach I took with my daughter 2 years ago. Up comes the photo. Because the AI automatically understands if I upload this photo, it says, hey, that's the person on a beach flying a kite. So I can ask it, show me pictures of people flying a kite, and this will come up. All done automatically. We can use this in the wild as well, animal recognition. And again, the key breakthrough is less than 10 years old. It's 2016, right? If you go back about a decade ago, the vision systems were not as good as humans in recognizing animals or any other thing you were trying to recognize. 2016, we got better than humans. That wildlife recognition in the wild, we can do that better than expert rangers. You can do this with vision, with video. You can try this, go to the Google video site, upload your videos, and you can say, hey, search for pictures of a car, and up will come every video where the cars are, and it'll show you that clip in the video. You can also upload one video, and it'll tell you all of the things that are in the video. There's a beach scene, there's a city scene. Later on, there's a skyline. And you can click on a red dot and go directly to that point in the video, all done automatically. We use that for self-driving cars. If you've seen a Waymo driving around, there are about 20 million miles self-driven, no human driver on public roads. This is not simulation. Right? Again, key breakthrough around 2016. 2016 seems to have been a magic year in AI. This was right before that. On top is the video of the car driving down something. Below is what the car was seeing back then. So I don't know about you, but I'm not getting in that car, right? 2017, It's seeing everything. It's seeing the pedestrians, the pedestrian crossings, the traffic lights, the fire hydrants, the people, everything. And that's 5 years ago. Now it's very, very good. Language, if you've done predictive typing on Gmail or on your phone, right, it's predicted by AI. And again, what's interesting is, I said there's a processing chip in here. It's all done on your phone. Google never sees your data. It can predict what you're going to type next, and we've never seen your data. It's all modeled on the phone for you and just for you. We can understand what people write and sketch and draw or handwriting. We can recognize sort of weird scripts like that as well. We can combine these. So translation combines the visual capabilities with the language translation capabilities. We can combine speech with language. We can do real-time speech translation. And this, again, works on your phone. If you have headphones or even just from your phone speaker, I can speak to you in one language, and you will hear it in your language. You speak back in your language, and I'll hear it in mine. It happens in real time. Right? Dozens of languages. I could go on, but we have limited time. So there's AI everywhere. Now, here's the part I want to get to, which is relevant to your industry. All of this AI has resulted in a set of building blocks, models, deep models of various types, for vision, for video, for language, for conversation, document analysis, right, website analysis, everything. And all of those models are being what we call democratized. We're making them available to everybody to use, right? So this was kind of the challenge. We have this thing at Google where if you do something well, management always asks you, can you 10x that? How do you make it bigger? So remember I started with this idea that there are there's a few tens of thousands of machine learning experts in the world. And again, they're not all Jeff Hinton, but they're smart and they're good and they're everywhere. But there are, how many do I have there? 5 million data scientists, right, and data analysts. They're not machine learning experts, but there are millions of them. Tens of millions of developers, software developers, never done any AI, never done any analytics, but they can write code probably better than I can. Hundreds of millions of business users, all of you, and many others in your companies, marketing people, business analysts, executives, salespeople, people who don't code, don't want to learn to code, right? How do all of you use AI? So remember I said to do AI, you need data, model, security, infrastructure. We've got that massive infrastructure I showed you. We've got everything is secure and compliant with all the local regulations. We've got all these models for all of these elements of video and vision and language and everything else I showed you. All that we don't have, which you have, is your data. So you provide your data, and you can use all of this other stuff we have at Google as a service. You just run your data, and you can use all of the same stuff that we're using every day. So the data, these are some of the kinds of data you're probably collecting already. If you're not, you should be, right? What your outlets are buying, how reordering, what products your customers are buying, your demographics, seasonality, all the kind of stuff. And these are some of the business problems you're trying to tackle. I won't read through all of these. I'll leave it up there. If you have a favorite one I missed, do let me know. So AI is about connecting that data to solving these business problems. So what we do is we call that Google Cloud. We take Google, which I just showed you, and we put it in a cloud service so you can, through a web browser or through an API, log in and use all of that in your own business. And you can also integrate with Google services so you get access to all these billions of users for marketing or commerce or whatever you want to do with them. The platform is called the Vertex Ai Platform. And again, the way it works is on top you have all of your data, all your customer data, consumer data, enterprise data, anything you have. In the middle is all of the stuff, the solutions and infrastructure all of the models, all of the AI stuff, all of the AI that does AI for you, if you don't want to write the AI yourself, all of that massive planetary scale computer, it's all there. I've had high schoolers log in and start using it. It's there to use. And you use it and you solve all these business problems. Right? And you can use it across the entire value chain of your business. Of course, there's marketing, right? You think Google, you think marketing and ads, yes. But there's all this other stuff, supply chain, application modernization, right? Managing all of your distribution networks, creating store experiences, in-store as well as online, and connecting the two, right? Intelligent inventory management, pricing, dynamic pricing, all of the rest of it. Everything can be optimized through AI. Right? These are some of the companies in the CPG space, including a lot of the food and beverage companies that are already using it. This is a small number of the tens of thousands of companies that are leveraging it. And you don't have to completely change everything. You just take a business problem that's most critical to you and plug AI into it. It's that simple. One of the things that is also important, and this is sort of my last thought here, is connecting with what consumers nowadays, particularly millennials, care about. There's a lot of research that shows that 70% of consumers prefer not to buy from a company that doesn't align with their values. 47% will actually ditch a brand if it doesn't align with the values that they've been loyal customers of. And one of the biggest values that we see is sustainability and traceability. The nice thing about running AI on the Google Cloud Platform, zero carbon footprint. Okay. And that is my end. So the last thought I'll leave you with now, sorry, I said that was the last thought. This is the last thought. Is that it's not just about technology. It's about changing the culture of your company, changing the culture of your business, changing the culture of your supply chain. Start thinking in this innovation culture, in a technology-driven culture, in an AI-driven culture. So plugging in AI is relatively easier, getting people to really understand how to use it and start thinking data first and data-centric is harder. Just like direct-to-consumer, right? Imagine taking a business that's primarily been dealership-oriented, like cars, or retailer-oriented, like wine, and changing the culture of the entire industry to think direct-to-consumer. Right? It's a cultural change. That's super important. And the way that I would advocate you approach this is from the head of Google X. That's the Moonshots factory. He says it's often easier and faster to make something 10x better than 10% better. We're trying to optimize something a little bit and just bump up sales by this or marketing by that. That takes a lot of effort. If you think sea change, how do we 10x this? I've got X in customers every year or Y in sales every year. How do I 10x that? Then you can't make incremental tweaks. You have to think differently. And often that actually takes you to your end goal faster and easier than if you just try to keep tweaking things. So I'll stop now. Happy to take questions. That's my LinkedIn if you want to talk later as well. Thank you.